Welcome back to the Scotti-BYTE channel, and this is Scott. So today we want to learn a little bit about using a Microsoft file sharing option, but inside of a LXD container. And so I've entitled this one LXD Microsoft Server. So there's a program in Linux called Samba, and it's the Linux file server and optionally a domain controller for SMB or CIFS file sharing for Windows. And SMB stands for Server Message Block, and then later the protocol, Microsoft started calling it Common Internet File Service. And so it's very common, even in a Linux-only environment, to see Linux people using Microsoft file shares because Microsoft file shares have kind of become ubiquitous in the world for file sharing. That being said, a lot of Linux hardcore users would use the network file system in Linux, which is NFS, and there's others like Apple File Services and so on. But Apple, Microsoft, and Linux tend to all use Linux or all use Microsoft file services at some point in time. So Samba is a very lean protocol. It's the program that we install and configure in Linux in order to provide Linux with Microsoft file services. And there is a file called /etc/samba/smb.conf, which is the configuration file, and it contains all of the settings to configure the Samba file server. And we're going to look at some of the very simple settings today to set up a very basic Microsoft file service and to share files out over your network. Now, the beauty of doing this inside of a LXD container is that it's going to be very lean and very small. So Windows file shares are created on the Linux host with account credentials, and those account credentials are actually separate from the Linux user account credentials, as we are going to see. So we're going to see how efficient Windows file shares in Linux are as compared with creating them on a Windows server. So I encourage you to go back to some of my other videos where I talk about configuring LXD and LXD containers from scratch. And at this point, I probably have about 40 videos discussing LXD. But there is one thing that I wanted to review here in order to be able to do what we're going to be doing. So in moving over to the /etc/netplan directory, there'll always be a file over there, a YAML file, that configures your network configuration. So in this particular case, this is an Ubuntu host using NetPlan, and this is the YAML file, and I'm just going to go over some of the basics in this particular YAML file. So to begin with, we have the name of our physical Ethernet controller, and we've talked about how to determine what that is, and that occurs in two places in the YAML file that I have here. It occurs in the Ethernet section, and it occurs in the bridges section. What we're setting out to do is we're setting out to create a bridge for our containers to get an address on the main LAN. After we set up the physical device name, then we have a section called bridges, and we have a bridge name here, and in my case, I'm calling the bridge 0. And then after that, we have a physical address, or not a physical address, but an IP address that we want to use. And this is going to be a static IP address of what I want my bridge to be on this device, and also its subnet mask. And if you have a server offering many features and functions on it, ideally you want it to be statically addressed. So this particular server on my network is being statically addressed at 172.16.1.50, and my subnet mask I've set up to be 16-bit. More typically, yours might be 192.168.1, and I've chosen here the address of 30 with a 24-bit subnet mask. The next thing you want is you want a default router gateway, and this is the new way of doing it in a NetPlan file. And the router gateway address that you might have on a typical 192.168 network might be 192.168.1.1, and it basically tells this server how to get outside your network and to the internet. And finally, we have our addresses for our name servers. Here I'm using the primary and secondary addresses for Cloudflare, and you can use any DNS addresses that you'd like. And then after I save this into this YAML file, I just simply do a sudo netplan apply, and it will process these things into the file. The next thing we need to do is in LXD, we need to create a LXD bridge profile that uses that new bridge 0 device. And in fact, if you do an if config on your system after doing that netplan apply, you'll find your physical Ethernet device is no longer getting a TCP/IP address, but your bridge is getting the TCP/IP address that you set in the netplan file. So here we're doing a LXC profile create bridge profile. This is assuming you've already initialized LXD and set it up. And of course, we've got that on the channel in several other presentations. Once you create that profile, you're going to edit that bridge profile by pasting the entire code block that I have here, which is simply LXC profile edit bridge profile. And then I've got it where I say bridge profile. Inside the container, it's always ETH0. Our NIC type is bridged. Our parent is bridge 0, and it's type NIC. So all that this does is that when we create containers with the bridge profile, they will receive an address on the main LAN, which is going to be required for our particular server. Now that we have our bridge and our bridge profile set up, you might wonder exactly why you would want to create a LXD container that has Microsoft File Share capability in it. Well, today, most people either buy a network attached storage or even probably a basic storage drive which attaches to the network, which is essentially a mini NAS, or they use file systems like Nextcloud or others to do file sharing. And what I want to emphasize today is how simple it is to set up this infrastructure without having to do any of those. So the first step that we have here is that we can go off and create a container. And we're going to do that with the LXC launch Ubuntu 22.04, which is the latest version of Ubuntu. I'm going to call this thing sys-server. That's the name of my container. I'm using the default profile, and that's for the root file system. And I'm also using the bridge profile that we just created by creating the bridge device on our LXD host and the bridge profile for LXD. And then I'm setting the limits to be 2000 or 4096 megabytes. And I really don't have to have it that large. I could really make it half that size, but I want to be able to support maybe hundreds of users. And then the limits, I can say use up to 20% of my CPU and set boot.autostart equal to true. So now it goes and creates this server, and it's created the server, and we can simply do LXC list, and you can see that my server is running. It hasn't gotten an IP address as of yet, but it will in a minute. In the meantime, I want to show you something else. I did a screenshot earlier when I looked at this particular server when I created it, and this is a screenshot out of LXD dashboard, and you can see that it showed me that the system was only using 177 megabytes of memory. So like I said, that 4096 is a whole lot. I had just created 1 or 2 shares, but the amazing part is the root disk space that container uses was 273 megabytes. And those of you watching certainly know that you can't create a Windows server in much less than probably 8 gigs of disk space. If we do our LXD list command for a second time, you can see that our container has now been granted an address of 172.16.1.101. In virtue of my bridged profile, that is an address on my main LAN. Let's connect with our new container with the command LXD exec sys-server and connect to the BOSH shell. And there we are, connected down to the console of the container into the root account. So with the creation of any new image or the installation of any new system, we want to do an apt update with an apt upgrade. And we're not doing the sudo command because we're already signed in as root. Now let's go create a user account for myself. So I'm going to do an add user Scott. And I'm going to give Scott a password. And I'm going to do a user mod -a g sudo Scott, putting Scott into the sudo group just as a convenience. And then I'm going to do an apt install of net-tools, again for my convenience because I like the format of the command ifconfig. So if we do an ifconfig, we can see we have inside the container an Ethernet device ETH0 that is granted the TCP IP address 172.16.1.101, which is on my main network. Now that I have a user account on my new container, I'm going to exit the console connection and do an SSH over to 172.16.1.101 and acknowledge the fingerprint, type in the password, and here I'm logged into the new system. And you can see here that the address 101 is there. It's also an IPv6 address, and it says that a system restart is required on this because of all the installation we did so far. So I'm going to go ahead and do a sudo reboot. Now that my LXD container is rebooted and I'm logged back in, the next step is to do a sudo apt install of Samba. And I'm going to put the -y to acknowledge it, type in my sudo password, and it goes off and installs Samba. Before we configure Samba, we want to make a backup of the configuration file, and the configuration file is /etc/samba/smb-conf or .conf, and we're going to put that into a backup file. Now that we have a backup file of the smb-conf file, we're going to go ahead and edit it with the nano editor with a sudo nano /etc/samba/smb.conf. The Samba configuration file is really a very nice template that guides you through all of the various settings of Samba. We're not going to go into all of these options because this video would be hours long otherwise, but the first one you want to be concerned with is the option workgroup equals, and by default, if you're not doing any Microsoft file serving on your network, you have a workgroup simply called workgroup. But you can name this to anything else that you might want to have out here. And then as we scroll down here, the defaults are just fine. There's nothing in particular that you're going to want to change in here. As we move down, the next thing that's interesting is the server role. Now, it's possible to make yourself a domain controller, and it's also possible to make yourself a member server on a Microsoft domain. We're not going to do that. Instead, we're just going to set ourselves as a standalone server, and a standalone server's goal is simply to share files. There are a lot of other settings in the Samba configuration file, and if we keep scrolling down here, you're going to see that the next section that is of interest to us is really going to be this section for the share definitions. And we're not going to edit any of these as of yet because we're going to go back here and look at some other settings before we make a decision about what we want in this section of the file. So we'll do a Control X. I didn't make any changes to the file, so it didn't ask me to save it. And our next thing that we want to do is we want to create a couple of settings. So I'm going to do a sudo add group SMBGRP, and that will just be the name of a group on my system, and we're going to use that as a shared Samba group, as you're going to see shortly. So it added that group to the system. The second step I'm going to do is a sudo user add as opposed to add user, and I'm going to do shares -g SMBGRP. So what this does is it goes ahead and adds a new user to the system called shares, and it puts them in the Samba group that we just created. The next thing I'm going to do is I'm going to do a sudo user mod -a g SMBGRP Scott, which adds Scott into the SMB group as well. And then I'm going to do a sudo SMBPASSWD, which sets the, or adds, with the -a command, it adds a Samba password to the Scott account. In this particular case, I'm going to type in a password. This does not have to be the same as your Linux password for the account. And next, I'm going to do the same command except for the shares account. And in this case, we never set a Linux password with the shares account because we did a user add, but we're going to have an SMB password for the shares account. And we'll go ahead and type it in as well. Okay, so now the next thing I'm going to do is I'm going to create a folder to store files for that particular account, and I'm doing a sudo make dir, and the -p simply says create the path if it doesn't exist, and it's creating a /samba/shares folder on the main disk. And it's done that, so it put that into the root file system. The next thing that we want to do is we want to set permissions for that, and we're setting the permission to be 0770, which allows people in that group to be able to access it. And then the last thing I'm going to do is I'm going to change the ownership of that file structure to be owned by the SMB group account. In order to add file shares to our Samba server, we need to go back and edit the /etc/samba/smb.com file, and we need to go all the way to the bottom of that file to where you noticed before that there was a section for share definitions. And you can go to the very end of this file, and in this case, I'm going to be adding a section called My Group, and My Group is going to be a group share folder of the path /samba/shares that we just created. Valid users of this group are anybody that is in the SMBGRP group. I say it's browsable, which means that when we access the server, you can actually see the name of the share, and it's also writable for the people in this particular group, and it is not read-only. So then I also created a personal share for the Scott account that I created because I gave Scott a folder also, and we're just going to point that to Scott's home directory, and we're just going to say that the only valid users of that Scott share are going to be Scott. It also is browsable and writable. So then I do a Control X and I save the file. In order to access this from my Linux machine, I can go to smb://172.16.1.101. And yes, of course, I could add this into my local DNS or into my host file, and I'd be able to access it by name. But we do that command, and there we go. We're looking at the shares that are up here, and I can access those shares. So, for example, we could access the Scott share because that's owned by Scott. It's going to prompt us. I'm going to say I'm a registered user. I'm going to put Scott in, and I'm going to go ahead and type in my password. And then you can see here, this is the main folder of my home account. And if I go and create a new document in it, and I just call this test document .text, and then let's say I create a new folder in here, and I say test folder. That's all there is to creating that. So now if I exit out of here, I'm signed on to CIF server here on the Scott account, and if I do an ls, you can see that test document and test folder both exist. So here we are in Windows, and if we come up here and simply select the top bar, and we type in //172.16.1.101, it'll access that node, and there is my group and Scott. Rather than connecting to Scott this time, we're going to connect to my group. We double click my group, and there it is. And so I can say create me a new folder, and it creates a new folder out there because that's a shared group and it's public the way I set it up. And so I can create a new text document out there, and all that works fine. If we go back up to this level and we type Scott, and we go ahead and access this, I can also access my test folder, put some data into it, and save it. So the reason we didn't have to provide any credentials in this case is because in Windows, my credentials, meaning my username and my password, actually matched the username and password of the file shares. And so it's using Scott to gain access to this particular share location. So back at the terminal for our CIF server, we can also perform a command called smb status. And smb status will give you the status of our server, but as you can see, we need to do a sudo smb status. It asks for my sudo password, and it lists out which groups access which things, and that's really great. So the other thing we have, and this is very important, it's easy to make errors in that smb.conf file, and there's a command called test_parm, which will test your parameters, and it comes back and says it's loading the services and everything is okay, and it's set up as a standalone server as we had done earlier. And then you can hit enter to see a dump of your service definitions, which simply lists out whatever's set up there. There's global settings that you can change in that conf file, We have a printers area, and yes, we could serve a printer out that's connected to this machine. Although since it's a LXD container, I don't have any printers obviously physically connected to it. And I have my share called My Group and my share called Scott. If you watch the channel frequently, you know that one of my favorite programs to monitor LXD containers is LXDware's LXD dashboard. And here I've drilled down onto my Mondo host and I'm looking at containers. And in this particular case, I'm looking at the CIFS server container. And you can see here that even with our 2 shares created, we're using 150 megabytes of memory and only 255 megabytes of disk space on the root. Now, once you start storing files out here, of course, that's going to grow, but you can store files in a location outside the LXD container, and I have some videos that discuss exactly how to do that as well. But the point is that this is a really lean and mean way to go out and use Microsoft file sharing in a self-hosted environment. So in summary, Samba is simple to configure on any Linux system. CIFS SMB file shares are created and managed in Linux, and they're accessible by Windows, Mac, and Linux users as well. In my demonstration, we saw how resource efficient a Samba share created inside of a LXD container can be as compared with doing the same thing with a Windows server. In a Soho environment, Samba can be a fast and efficient way to create Windows shares with multiple users. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell and that like button, and we'll see you next time.